This next example has a similar case with the previous one, but with a different set of parameters. Welcome to hydrology. The problem includes a watershed of 2,000 hectares area. A 10-day storm has been recorded with the following properties, and we are tasked to compute for the change in soil moisture and also the final soil water storage. Checking on the record, we use the water budget equation of inflow less outflow is equal to the change in water storage. We start by categorizing each parameter, such as precipitation under inflow, evapotranspiration, average stream flow, irrigation input, and groundwater recharge all are under outflow. Then the change in soil moisture lies under change in water storage. The last input in the table, which is initial soil water storage, is not a part of the equation. This parameter shows the current moisture of the soil prior to the storm. Place the values for each parameter, thus having the change of soil moisture as 12 cm less 26 millimeters minus 1.2 acre-feet less 24.5 inches minus 3.2 cubic feet per second. There is not much we can do for now as each term has a unique unit. This means we have to go through converting them into one unit only. Take the equation and align units into centimeters as this is required by the problem. The first term then is kept as it is, and we move to the next term, 26 mm. This is converted into centimeters, but a factor of 10 mm is to a centimeter, converting the second term into 2.6 cm. The next term is 1.2 acre-feet. We cancel out acre by multiplying the factor of 43,560 square feet per acre. Then multiply the square of 3.28 feet is to 1 square meter. Then again, multiply the factor of 10,000 square meters is to a hectare. Now that acres turn into hectares, divide the term by the catchment area of 2,000 hectares. This will totally take out hectare and acre from the picture. Next is to convert feet into cm, and that is by using the conversion factors of 3.28 feet per meter and 100 centimeters per meter. So the third term is converted into 0.00741 cm. For the next term, which is 24.5 inches, multiply the conversion factor of 2.54 cm per inch, and this results to 62.23 centimeters. The last term in the equation is 3.2 cubic feet per second. First is to take out seconds by multiplying the conversion factors of 3,600 seconds per hour with 24 hours per day. Then multiply the duration of 10 days, thereby eliminating time from the term. Next is to convert cubic feet into cm, and that is by multiplying the square of 3.28 feet as equal to 1 square meter. Then 10,000 square meters is to a hectare. Now that the unit is transformed into hectares, divide this by the catchment area of 2,000 hectares. At this point, the only remaining unit is feet, which should be converted into cm, and that is through multiplication of the conversion factors of 1 meter is to 3.28 feet and 100 cm is to a meter. With other units canceling out, the remaining unit is cm. So take all values according to the operation and get 0.3918 cm. The water budget equation is then delta soil moisture is equal to 12 cm minus 2.6 centimeters less 0.00741, 62.23, and 0.3918 cm. Delta soil moisture is equal to negative 53.2292 centimeters. The second requirement is to solve for the final soil water storage. This is the initial soil water storage plus the change in soil moisture. From the table, the initial soil water storage is 4.6 hectare-meter, and the change of soil moisture is negative 53.2292 cm. Convert the first term to align its units with the required. So take out hectare by dividing it with the catchment area. Then multiply the conversion of 100 cm per meter. The initial soil water storage is then converted as 4.6 times 100 divided by 2000, resulting to 0.23 cm. So the final soil water storage is 0.23 plus negative 53.2292 cm, which becomes negative 52.9992 centimeters.